Hello, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Umar Aiman Defazullah from Group 5. It's going to present the introduction of membrane separation process. There are a lot more you to know about membrane separation process. Uh, this process is very widely used in our daily life, and you can even use it or apply it when you are at home, such as the water that you drink or you use to clean the dish uh, is already filtered by the filter, and the filter have uh, a process that we call membrane separation, where it functionally used to filtrate all the dirty bacteria or a particle that we have to reject in order to use it safely. The first important thing that we have to know is the membrane separation process is based on presence of semi-permeable membranes. The principle is quite simple. The membrane acts as a very specific filter that will let water flow through while it catch suspended solids and other substances. Membranes occupied through a selective separation wall. For example, the membrane in the filter will remove the the big size particle, but with in conditionally. It must have a size of pore that smaller than the particles that it should be removed. Okay. Second, it used for feed products with a range of viscosity, with including high viscosity products that can otherwise be difficult to process. A wide range of different membrane filtration products also ensure that the best possible solution is available for each particular application. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Normalina binti Bakar, and I would like to present process and mechanism of membrane separation. Membrane separation process is very essential in separation industry. The process is conducted without heating, and thus use less energy than conventional thermal separation process, which are distillation, sublimation, or crystallization. Membrane is a selective barricade that allows the separation of some species in a fluid by combination of filtering and adsorption diffusion method. Separation is completed by selectively permitting one or more components of a stream through membrane while hindering the channel of one of other components. Membrane separation also detaches components over a huge range of particle size and molecular weight, which is from macromolecular materials such as starch and protein to monovalent ions. Membrane can perform separation by three different mechanisms. First, by using pores that some species can pass but cannot by the other species. This mechanism is also known as size exclusion. Second, by selective retardation by pores when the pores diameter are close to molecular size. This mechanism is also known as pore flow. Third, by dissolution into the membrane, migration by molecular diffusion across the membrane, and reappearance from the other side. This is also known as solution diffusion.
This is the differences between reverse osmosis, ultrafiltrations, and nanofiltrations. Okay, the first thing we can say is the separate molecule. For the reverse osmosis, it separates the small molecule. For example, is the glucose. And then the ultrafiltrations, it separate the macromolecules such as bacteria and yeast, and the last one is nanofiltrations, it remove the organic molecule. Second, in the aspect of pressure required, for reverse osmosis, it required high pressure and it used as method capable of remove large particle. For example, for reverse osmosis is food manufacturing, processing, and packaging in the food and beverage. And the second one, the ultrafiltrations, it required low pressure and it process used to remove macromolecule and allow another micromolecule to pass through the membrane. For example, is drinking water purifications. And the last one is nanofiltration. It required less pressure compared to the reverse osmosis and it used for softening the solutions. For example, it can use to remove divalent ions to the soften hard water.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zikri Akmal bin Azhar. Now I am going to present the advantage of membrane separation. This is 5 advantage of membrane separation. Number 1 is clean technology with operational ease. In membrane separation, no complicated heat transfer or heat generating equipment is required. This process could be operated at the ambient temperature. Number 2 is have a very large number of separation needs. Because membrane process can separate at the molecule scale up to scale at which particle can actually be seen. This implies that a very large of number of separation needs might actually be met by membrane process. Number 3 is high selectivities. Membranes can be produced with extremely high selectivities for the component to be separated. In general, the value of this selectivity is much higher than a typical value for relative volatility for dissolution operation. Number 4 is better for the environment. Membrane processes are potentially better for the environment since the membrane approach required use of relative simple and non-harmful material. Number 5 is energy saving. Membrane processes generally do not require a phase change to make a separation. As a result, energy requirement will be low unless a great deal of energy need to be expended to increase the pressure of the feed stream in order to derive permeating component across the membrane.
Assalamualaikum and hi, my name is Intan Salwani binti Muhammad Sabri and I will talk about the disadvantages for membrane separation. So the first point is the membrane selectivity is not infinite. This will result in the mixture is not fully separated, which is the permeate will contain significant amount of substance, which is the substance should be in the retentate solution. This is because the membrane selectivity is not infinite. Hence, the separation is not 100% successful. So, the second point is the separation cannot be easily staged, unlike distillation column, which is designed with many number of stages. So, there are two types of pattern in membrane separation, which designed with high selectivity with few stages, and also low selectivity with many stages. So, the increasing in the number of stages will decrease the selectivity of membrane. And next, we move to the next point is the membrane separation has chemical incompatibility. It occurs when the solution contains high concentration of various organic compounds. The various organic compounds will against the polymer-based membrane. This will make the substance can dissolve, swell, weaken to the extent such the membrane lifetime unacceptably short and also the membrane selectivity unacceptably low. So the next point is the temperature limitation. So the membrane separation will not able to operate at condition which much above from the room temperature. This is because the polymer base with large fraction could not maintain their physical integrity above the 100 degrees Celsius. Based on these limitations, so the membrane separation process cannot be made compatible with some chemical process condition. And we move to another point, which is the last point of these advantages, is the following case. The membrane separation can be saddled with major problem of fouling. This situation occurs especially when the solution or the substance that need to be separate are difficult to be removed. This could restrict the permeation rate through membrane. So based on this factor shows that the membrane separation process is essentially unsuitable for such application. So that's all the disadvantages for the membrane separation.
Assalamualaikum, my name is Nurudiana. Today I'm going to talk about the applications as well as the safety precautions of this experiment. So membrane separation process has special recognition in water treatment process. Membranes are barriers that allow water to pass through but stop unwanted substances from passing through with it. It works much like the cell walls in our bodies. Technical membranes filter out salts, impurities, viruses, and other particles from water. Other than that, we can use cold pasteurization and sterilization with suitable membranes instead of high temperatures treatment for the removal of microorganisms or bacteria, which is way more economical in terms of energy consumption. Specific applications of membrane processing in the dairy industry include fractionation of milk from whole milk, removal of bacteria and spores from skim milk, and production of milk protein. Reverse osmosis has become a standard process in the food industry. It is used for sugar concentration in the cereal processing industry and also for concentration of juices. It deserves a special look because of its suitability for a wide variety of applications. To reduce true errors, we recommend to take the exact value from the scale, and the readings must be taken in more significant figures. To obtain an accurate average weight value, measure the weight of permeates for at least 3 times. To acquire accurate value of weight, we have to run the system for more than 5 minutes to ensure the stability. To avoid interruption, make sure to open and close the sampling valves at the same time. Lastly, assure that a big container was being used when collecting the samples to hold up the volume of the sample and to avoid it from spilling out.